Vidyalankar Institute of Technology. More than 15 years, 1-5. And you can see my academic profile. You must know your teacher before you know anything about subject. And my domain is system architecture. I always teach subjects of system architecture, where I teach microprocessor, microcontroller, computer organization, embedded systems, till IoT, including OS. And of course, system architecture works with programming. So I teach programming languages, C, C++, Java, Python, and assembly. For you, I'm there for microprocessor. Let's see what is the look of the subject. This is how your subject looks in terms of Mumbai University syllabus. It is called scheme. There are total 6 modules. I'll be teaching all the modules sequentially. 1, 2, 3, 4, 5, 6. You will appear for 80 marks of final examination from university, to internal test at your institute level. We call IA1, IA2, like other subjects. 20 marks, average 20. And this subject has term work practical of 25 marks. There is no practical exam. So total is 1 to 5. And 4 credits, 3 credits for subject theory and 1 credit for laboratory. This subject has a prerequisite, and you know what is that prerequisite? That is COA of semester 3, because when I taught COA, I said on the top of COA, you will study microprocessor. So my advice will be, this is week 1, find some time, read fundamental concepts of COA, typically memory and processor related concepts. It will be useful in microprocessor. Resources, the best textbook is 8086 Microprocessor and Interfacing by Douglas Hall. You can find one copy in college library. Issue it, use it. It's a very nice textbook. You can start with this textbook. As we go ahead, I will share some more textbook. As usual, you will get all soft copies of the material in our app called StudEase. Already notes of all modules are available. I have prepared those notes. So what I'm going to teach, from exam point of view, you will get material in the form of soft notes through app. And additionally, I will share all these presentation in the form of PDF. I always do it. In COA also you have seen. And that will be your reference notes. So in all materials will be directly provided. Lesson plan already I have submitted. You will see that in our app. I need total minimum 14 sessions, 14 sessions of 2 hours and 15 minutes, 630 to 845. Possibly, I may require 1 or 2 extra sessions. In COA, I have completed everything in 14 sessions. but microprocessor is little more. I will try, but possibly we will require one or two. But anyway, that is the future. I will update as we go ahead. Now we are ready for our session 1 with this small preliminary. You keep some notebook with you when you are attending this session. You write whatever point you feel important. You prepare your own notes. Already I said all soft copies of notes will be available in StudEase. What I'm teaching, it will be available. But additionally, you can make your own notes. I will not do any dictation because practically it is not possible due to time constraint and the nature of our session. So I'll be mainly focusing on conceptual discussions, your understanding, and we always communicate through chat box. Okay, so now we are ready for our session. This is the agenda for session 1. So today we will focus on bringing microprocessor. Okay, what exactly is a microprocessor? We will start the way we started in COA for initial half an hour, and then we will bifurcate. One track goes in COA, other track goes in microprocessor. We will discuss what is a bus and how these buses are classified. We will understand their significance through reference of memory. We will start 8086 and we will reach architecture of 8086. That's the plan for the day. Let's see how much we can complete. If all is good, type magic words YES, which indicates all is good. Okay, I can see some responses. That is YES. Okay, fantastic. So everything looks good. Let's start. Okay, all is good. And here we start. This is where architecture of 8086 starts. Okay, anyway, we will see how much we can reach. There is one question in front of your screen, and you can see some computer appearing on the screen. So my question is, what is a computer? Just like we started in COA, we will start in microprocessor. So for you, what is a computer? I need quick answers in chat box. What is a computer? Quick answers in chat box. Okay, so we start with Mustansir. I remember he is a part of COA. He was, in fact. It's an electronic machine which processes the input and produces the output. That is correct. Moin says it's an electronic device. Yes, that is correct. Waiting for others. What is a computer? That is where we have started. Ten seconds more. It's a computing machine. That is what Ashish is telling. output devices for programs. Okay, that is Siddhi's answer. Electronic device which processes the information. Yes, that is Ved. Electronic machine which perform tasks based on IO. Okay, Divya, very good. Anyway, that is correct because it's subjective. Every person will have their own definitions of computer. Let's take one definition which is technically required. We always say computer is electronic machine which processes the data very fast and generate valid results. I think you will agree it's electronic machine because if you open your computer out of curiosity, if you see this computer called Raspberry Pi, okay, this is called RPi, you will find there are lots of integrated circuit. Okay, this particular device, it's called integrated circuit, we call IC, and such many ICs you will find in your computer. So we say it's electronic machine and it processes the data like you add, subtract, or prepare a merit list, and it always generates the valid result. It is expected that your computer will always give correct results, correct output. And I think everybody will agree that computers are everywhere. Okay, we see in banking, we are using in education. What we are doing is through computer. Mobile is also a computer nowadays, and industry has a wide range of applications. So we agree that nowadays, along with human, there are computers. They are everywhere. We defined what is a computer. My second question is, can you tell me what is the minimum requirement if you want to work with the computer? I repeat, what is minimum requirement for working of a computer? Your answers in chat box. Okay. Okay. I can see variety of answers. 10 seconds. I want to see who are giving quick responses. And what are the responses? Okay. Okay. Now I'm not referring names because I can see your answers. Okay, 10 minutes are done and I can see many answers. All of you are giving correct answers. Let's see, if I want to work on my computer, if I want to process the data, if I want my computer should generate valid results, if I want I should teach online through computer, what are the minimum requirements for my computer? Here we go. I said your computer is electronic machine which processes the data. How my data will come into the computer? Because if you want to process, you must provide your data. You must have some facility to give the data. For that, we need some hardware devices which are called input devices or input unit. You can see. So through input unit, like keyboard, you will read the data because definition of computer is our reference. It processes the data. So how data will come? Because I'm talking, because you are listening? No. It's through hardware called input unit, like keyboard. If computer is a device which processes the data, how you will see your data, how you will see your result, how you will see your correct result. For that, we need some hardware devices which are called output devices or output unit, like monitor. I can see in chat box, I can see some responses also, which is very good. You can see your results using output devices, output unit, like a monitor. And hereafter, till the end of our subject, I'm going to refer input and output as I/O. So whenever you will read a word I/O, that means input output. Okay. So magic word is yes, I/O is input output. Again, computer processes the data. $1 million question is, who is going to process the data? How my data will be processed? Hardware which processes the data, hardware which generates valid result, it's called CPU, and more precisely, it is called microprocessor, which is our subject. So we are going to look into this particular device in a subject of microprocessor. What is the magic of microprocessor? So all processing of data, whether simple or whether complex, you always do using hardware called CPU, Central Processing Unit. More precisely, it is called microprocessor. Okay, that is where our subject comes in discussion. I know how to read, I know how to process, I know how to display, but occasionally I require a facility to see my data, to refer my data, maybe after 2 hours, maybe after 2 years, maybe after 20 years. How I'm going to store the data? For that, we need some hardware devices which are called memory devices. Typically, the memory that I will refer is called RAM. So one more convention in my session, anytime when I use a word memory, I refer to one memory called RAM, that is random access memory. And you are well aware about memory organization referring to COA. I know how to read, I know how to process, I know how to display, I know how to store. These blocks are called functional blocks of a computer, the title of my presentation. Any computer stands on 4 pillars: the input, the output, the microprocessor, and the memory. So these are the 4 main pillars of our computer. Your mobile phone works on those 4 pillars. Your mobile phone is also a computer. Now there is a question which requires observation. My question is, can you tell me what is missing in my computer? What is missing in this diagram? Just a hint, no functional block is missing. You need to identify what is missing? Okay, I think COA guys, they can recollect, because this is where we started module 2 of COA. Yes, that is right. I think those answers are correct. The bus, the connection, and connections. That is perfect. I'm so sorry. So that is correct. The question is that if I read some data like 15 and 20 from keyboard, how it will reach my microprocessor? Because there is a gap. If my microprocessor adds some data like 1, 5 and 2, 0, how it will reach the output device or memory? Because there is a gap. This gap we have to bridge, and we bridge it using a concept called bus. Okay. Now, what is a bus? Let's understand. Bus means the group of conducting path or metallic wires. I hope you are sitting with notebook. A gentle reminder, what you feel important, make a note. So everybody's notes will be different and we get good variety. You can communicate, you can share among yourselves. All the main notes you will be getting through our app. In fact, they are ready. Coming back, bus means group of metallic conducting path, copper tracks. If you have seen the motherboard, you will find shiny copper tracks, or group of wires, if you take it outside, used to carry data from one functional block to other functional block. So my data from input unit will reach processor via bus. My data from processor will reach memory via bus. My data from processor will reach output device via bus. And bus is an interconnection between all different functional blocks. Okay, now my computer is complete. You may get a question for 5 marks. What is a bus and what are different types of buses? Okay, let's go into. Any computer needs 3 buses. One is called address bus. We abbreviate AB. Second one is called control bus. We abbreviate CB. Third is called data bus. We abbreviate DB. There is no computer which will work without any of these buses. This is one main agenda for the day. The address bus, the control bus, and data bus. And combination of these 3 buses, address bus plus control bus plus data bus, it's called a system bus, that is SB. So essentially, if you see the computer diagram carefully, some arrows that you see, they are not decorations, but that is a system bus. So this is my system bus, this is my system bus, and this is my system bus. So via system bus, all communication happens inside a computer. And we need to little more understand about these buses. But before that, if you have any questions, definitely I will like to answer your questions. So day one, hour one, my question to everybody is, any questions? Check if you have any questions before I move. We are in the subject. Okay, no questions. No questions. I will appreciate if you can respond so that it's a dialogue and not a monologue. Okay, looks good. We can go ahead. Okay. Now we need to understand what is the significance of these buses, because I said your microprocessor subject is a ocean. Hats off who designed this particular subject, where they have included 3 major microprocessors for limited hours. So you take any microprocessor, very fundamental requirement is a buses. So we need to explore it. Okay, let's explore a concept of buses. Here we go. Now you need to observe, okay, see the title of my slide and you should be alert on chat box, because again, some questions will be there. Yeah, Vansh, I'm doing the same thing. I'm working on your question because we need to understand what are the types of buses. So next 2-3 slides and next around 20 minutes, we will complete buses. Okay, so be ready. Some interaction, some questions. Do you agree that all major functional blocks of my computer are hardware devices? Of course, everybody will agree because keyboard, monitor, memory, microprocessor, they are all hardware. So this is one observation. Question is, if my computer is a hardware device, can my hardware will work directly in a computer? I want your response for this question. Can my hardware work directly in computer? Okay. People are saying no. I will be happy if you can add why not. That is a correct answer. Big no is a correct answer. But I'll be happy if you can add why not. Assume there is a power supply. Assume they are interconnected. Okay. Okay, very good. Okay. So I can see Vansh and Mustan see they are little close to the answer. Okay. Hardware interact with the processor, but how? That is correct. And the answer is big no, like you said. We need software to run the hardware. So if you want to work with your computer, what you really require is software. So you take any computer, always there is a hardware and there is a software. It is not a choice, it's a need. Now the question is, what is a software and how I get software? Let me see what you think, how to get a software. Yeah, that is correct. Computer understands binary language. That is correct. but how you work on it, for that we need software. So how you will get it? How you will get software? Any inputs? Chat box. Operating system is an example of software. Question is how you get. What is a way? The answer is, if you want to get any software, yes, that is correct. I can see some answers like Vansh is a little close to the answer. Anyway, so if you want to get the software, then the only way is through a program. Either you write the program or you get the program which is already done. Like operating system, you always get. Okay, a big team, a big giant companies like Microsoft, they have made that program we call as an operating system. But if you take applications, what we use in day-to-day life, then that we normally code. Okay, and for that, all reasons, what we need is a program, and program means the group of instructions or set of instructions to perform some task. Okay, now this particular observations are very significant, because now we are going to work on more understanding of buses, okay, with these particular observations. So summary, my computer functional blocks are hardware. There are 4 blocks. They are interconnected via buses. Bus is a conducting path, metallic wires used to share data between the blocks. 3 buses address, control data. Combination is system bus. My computer cannot work directly. It's a hardware. It needs software to run hardware. And to get software, we must write a program. We must get a program. Okay. Now there are 2 questions, and you need to answer using chat box. Let me see who answers quickly and correctly. Question 1. If my computer works on a program, who executes my program? Which part of your computer executes your program? Yes, your answer. No, compiler is not a correct answer. Compiler itself is a program. OS is not a correct answer. OS itself is a program. RAM is not a correct answer. My question is, which part of computer executes your program? The answer is, it's our subject called microprocessor. It's a microprocessor which executes your program. The life of microprocessor is to execute the program. So we must know the person who runs my program and the program which runs my computer, how it works. Microprocessor is the correct answer. Okay, so who executes the program? It's microprocessor. My second question is, if microprocessor executes the program, any program, where you store the program, which processor is executing? Where you store the program, which processor is executing? very precise answer I want. You are coming from COA. Yes, Tanay is correct. It's RAM. That is random access memory. Yes. Okay. That means if I go back, then my program is always stored in RAM for execution. And this program is always executed by microprocessor. That's the observation or conclusion. Okay, that's the reason why microprocessor is called brain of a computer, because it makes your computer to work. Okay, now let's map all these buses and let's understand how these buses are important in this process. Which process? To run the program. Okay, so you need to listen this concept carefully. Okay, let's go on with significance of buses. Okay, for that, let's take a memory called RAM. Okay, this is my RAM. And let's assume that I have a program with some instructions or statements. Okay, like instruction 1, instruction 2, like that, instruction 50, or statement 1, statement 2, statement 50. Now this program you always store in RAM. Okay, that is main memory. The other name is main memory. Okay, typically referring to COA, because this fundamentals you have studied, we need for microprocessor. Your memory, like RAM, has millions and billions of locations, one after the other. You can see. Okay, so this is a location in memory. This is a location in memory. This is a location in memory. Like that, there are billions of locations. 10 to the power 9. That location, it's called memory cell. Observe it. Okay, so this is my memory cell. This location is memory cell. This location is memory cell. This is memory cell, and goes on. Every location has a unique address. Observe it. So if you see the diagram carefully, you will find my start location has address 0000. Okay, next location has address 00001. Some random location has address 10,000 H. H stands for hexadecimal. Okay, you have studied number systems in lecture 1 and chapter 1 of COA. So hexadecimal means digits 0 to 9 and alphabet A to F. A represent value 10 and F represents value 15. That is what is H, hexadecimal. So all these values are hexadecimal. And every location can store 8 bits. Observe it. So this is some location whose address is 10,000 H, I'm assuming. Okay. And this location can store 8 bits, D7 to D0. And this is replicated. Okay. So this location can store 8 bit, this can store 8 bit, this can store 8 bit, this can store 8 bit, and so on. Typically, D7 it's called MSB, and D0 is called LSB. Quick answers. What is MSB full form? LSB full form in chat box. Let me see how much you know COA. Sorry. That's great. You know COA. Yes. All answers are correct. Yes. All answers are correct. Perfectly correct. Let's continue. MSB stands for most significant bit. Okay. Highest power of 2. अपने कन्वर्जेंस पढ़ा है COA में. LSB stands for least significant bit, lowest power of 2, 2 raised to 0 and 2 raised to 7. Okay, that is what is MSB and LSB. Now comes the mapping part. Okay, so you need to listen my statements carefully and understand. If required, you can note it down. In the beginning, I said my program I always store in this particular memory. Okay, let's go back again to our computer so that if anybody has lost the track, they will understand. I said the program that you want to execute is always stored in this memory called RAM. And who runs the program? It's a processor, microprocessor, who runs the program. Okay, so these two elements we are currently focusing. Say for example, currently I'm running PowerPoint presentation. Okay, you are able to see my PowerPoint presentation screen because I'm running a PowerPoint program. That program is in RAM of my laptop. And my processor is executing that program because I have double clicked on Microsoft PowerPoint at the start of the session. Okay, so where is my program? In RAM. And who executes the program? Processor. Okay, now comes the mapping of buses. Okay, so you can answer if it comes for 5 marks. If I claim that my program is stored in this particular memory called RAM, the very first question is how processor will understand at what location in memory my program is stored. Because there are billions of locations if you are good listeners. So processor must understand the exact location where my program is stored, like this. Observe it. We are back to our memory and buses. Okay. Say for example, if this particular program is stored from this location, okay, 10,000H. This program is stored from location 10,000H. Then using 10,000H, processor will understand this is the start of the program. And this particular information you share using address bus. So address bus is used to carry location of memory where program is stored or data is stored. Okay, so your operation always starts with address. अगर आप अच्छे से सुन रहे हो, देख रहे हो, you will see that ये जो बसेस है वो मैंने एक ऑर्डर में लिखे हैं. वो ऑर्डर बहुत सिग्निफिकेंट है. This is a order your buses are used. So the very first requirement is address bus, where to go in memory to find program or to find data that you share via address bus. Okay. So through address bus, like 10,000, processor understand, yes, this is the location program is available. Let us assume that through address bus, my processor understands my program starts from this location. Okay. That location is 10,000H. Okay. This is the address. This we carry on address bus. So processor will reach this particular address. But how processor will understand what to do at this particular address? Because referring to COA, you will agree that memory is a Boolean device. BOOLEAN. Boolean means two possibilities. Okay. What are the two possibilities? On memory, you can either read, or on memory, you can write. Okay. These two operations are possible on memory. So how processor will understand at this address, if I go via address bus, what I want to do? Am I going to read or am I going to write? For that, you need control bus. So control bus carries control signals which tells processor which operation you want to do. Like processor wants to read, processor wants to write on memory. All this you communicate via control bus. Okay, so that hierarchy is important. Address followed by control. Okay, let us assume via address bus, you tell processor go to 10,000H. So processor will reach this address. How? That all we are going to study in coming days. Okay, this is just significance of buses. Let us assume via address bus, processor understands I will go to location 10,000H. This will be communicated on address bus. Okay, so processor reach this. Via control bus, processor understands I want to read this location. Read. Okay, you communicate via control bus. Now the question is, if you read this particular data or instruction like I1, observe it, because my program starts from this. The first instruction is I1. So if you read this data, if processor reads this data or instruction, how you will get into the processor? Because memory and processor, they are physically different. Memory can store, cannot execute. Processor can execute, cannot store. So you have to move the data between memory and processor. Repeat. Memory can store, cannot execute. Processor can execute, cannot store. Okay, cannot store program. More precise. So how you will move the data? For that, we need data bus. So the processor will read this particular data or this instruction, and via data bus, your processor will get it. So the third in the sequence is data bus. Address bus tells where to go. Control bus tells which operation to perform. Data bus indicate carries actual data, actual instruction of your program. That is a significance or functions of address bus, data bus, and control bus. That completes our second point, mapping of buses and their functions. So again, I'm waiting for your questions. And once again, my question is, any questions? Please check it out if you have any questions. One question I have seen, can you repeat control bus? Yes, I will. But let me collect all the questions before I go for a quick summary. Okay, I'm waiting for your responses. Okay, from where data bus takes the data? From memory. To processor or to IO device. Currently, I'm using processor and memory for example. So your data can move from memory to processor or to IO device, typically output device. That is what is our block diagram. Control bus has many other control signals. Read and write are most common signals. So there are many signals. Okay, we will see as we go into 8086. Any other questions? Okay, now I will quickly summarize and we will proceed. Okay, so second point we have completed, that is significance of buses. This is very critical for understanding microprocessor because I know we reach Pentium processor and people still don't understand what is address bus, data bus, and control bus, because in every processor you will find that system bus, which is a very fundamental need. Okay. There are no further questions, so let me answer the questions which are pending. I will quickly summarize. Okay. Let me start with the same statement where I left. It's a processor which executes the program, cannot store the program. It's a memory which stores the program but cannot execute the program. Of course, to bridge this gap, your processor must go to memory to find in this memory RAM what is the location my program is stored. That location, like 10,000H, where my program is stored or program starts, you communicate, you carry, you share via address bus. So address bus carries location, address, or location information of your memory. Where to go? Answer is address bus. Let's say processor knows I want to go to a location 10,000H. This will go on address bus. Second question, which operation I want to perform at this address? Because I can perform read, I can perform write on memory. Okay, we are taking memory as an example. That you indicate using control bus. Control bus carries different control signals which indicate which operation you want to perform. Like I want to read. So read is a control signal you will carry through control bus. Or I want to write. So write is a control signal you will carry through control bus. What to do? The answer is control bus. Where to go? The answer is address bus. Let us assume through address bus, processor reach 10,000. Through control bus, processor reads this data or instruction, this data or instruction you have to transfer to the processor, because memory cannot execute. Okay, you have to take it into the processor. That actual instruction, actual data, you carry, you transfer via data bus. So data bus, as the name suggests, carries actual data, actual instruction, and that is the last element in the sequence. Okay, so good engineering question is arrange your buses in proper order according to the usage. Okay, simple question, but that checks the fundamental understanding. Okay, let's go ahead. Now we will go into 8086 microprocessor, okay, which is our next point of agenda for the day. And we are completing around 1 hour. A good discussion and good flow we have maintained, because we are going as per the point of agenda. What you see on screen is 8086 microprocessor whose age is around 46 years. Okay. So what is the age of 8086 microprocessor? If somebody asks, the approximate age is around 46 years. Somewhere in 1976 to 78, more precise, somewhere in 78. His processor was invented by Intel. It's a Intel processor, you can see, okay, and you can see the year also, 78. And this is a chip called 8086 microprocessor, and your first computer was based on a processor 8088, okay, which is a clone of 8086. Anyway, let's go into 8086. Let's start with a concept of pipelined architecture, okay, because this I require to enter 8086 microprocessor. I know you have studied concept of pipelined architecture in COA. Your colleges have started. So marathon has started. And you might have completed all this in your institute, college. Can you tell me what is the meaning of pipelined architecture? Anybody in chat box? Before I go into features, no doubt I'm going to features, but just want to see what is your understanding, because I need it maybe in next half an hour. Yeah, great. I'm very happy that you are familiar with those words, fetch, execute. Okay, that's perfectly correct. So those words you can recollect from COA. Anyway, no problem. Let's start with the features of 8086 microprocessor. Okay, this we will be covering in around 10 to 15 minutes, because just points you need to remember. Your 8086 microprocessor is a 16-bit processor. Observe it. The data bus is 16-bit and address bus is 20-bit. Okay, that's the reason we spend quality 1 hour to understand what is a data bus and what is an address bus. Any processor starts with data bus and address bus. Okay, so 8086 has 16-bit data bus and 20-bit address bus. Data bus is D15 to D0. Of course, this is LSB, this is MSB, and address bus is A0 to A19. This is MSB and this is LSB. Okay, so total 16 and 20 for data and address. This processor support maximum 1 MB of memory called RAM. What I mean is, if you want to work with 8086, okay, the very old processor where history started, the maximum memory is 1 MB. Can you tell me how this value we are getting? Because here there is some mathematics. It's not a difficult mathematics. It's not scary. So how it is 1 MB? Yes, that is right. This all you have done in COA, okay? But we need to revisit because these questions might come in exam for small marks, okay? Just to test the knowledge. Yes, all these answers are correct, what you are telling. The reason is, let me go to the Microsoft Word for 5 minutes so that everybody will understand if they have not studied in COA. I will switch my program and I will go to Microsoft Word. Observe it. On your screen, there are 3 important formulae that you must remember, okay? Before I talk anything further, those formulae are very simple. In memory organization of COA, you have studied cache memory. There you have referred it. 2 raised to 10 is 1 KB, that means kilobyte. 2 raised to 20 is 1 MB, that is megabyte. And 2 raised to 30 is 1 GB, that is gigabyte. Okay. Why these 3 values are important? Because if I go ahead, maximum memory supported by any processor like 8086 is given by a very simple formula, M equal to 2 raised to A. Okay, of course, this again you have to remember, M is maximum size of memory, of course RAM, and A indicate number of address lines. See this carefully. That's why address lines are so important and they are number 1 in sequence. Okay, because your number of address lines will decide what is the maximum RAM supported by a processor. Let's take one example in day-to-day life. Under normal discussions, we say that my laptop has 4 GB of RAM, or my friend's laptop has 8 GB of RAM. Now, how those values are coming? 4 GB, 8 GB, those all values are coming because of address bus. So it's the address bus which decides maximum memory. Simple formula, M equal to 2 raised to A. Okay. Now let's take our processor. Ours is 8086 processor. So let's take it as a reference and apply the formula. Okay. So if my processor has 20 address lines, and if I apply a formula, M equal to 2 raised to A, my A is 20. That is where we started. Features of 8086. My M becomes 1 MB because 2 raised to 20 is 1 MB. Observe it. Okay. 2 raised to 20 is 1 MB. That's a direct formula. So very simple. And that I have used here to get maximum memory supported by 8086. Okay. So you might get good questions in your exam. How you will justify maximum memory supported by 8086 is 1 MB. Okay, so you need to justify using those 3 steps. Okay. Now let's take one more example so that we can go back to features and this point will be covered forever. There is one question. Question is, what is the size of maximum RAM, that means memory, used with a processor whose address bus is 32-bit? My 8086 address bus is 20-bit. But suppose my processor is high-end processor, like 80386. Okay, your higher modules. Then same formula you can apply. You can see M equal to 2 raised to A. So M equal to 2 raised to 32 because number of address lines are 32. Now there is a small mathematics which is required here because direct value is not available. We know 2 raised to 10, 2 raised to 20, 2 raised to 30. So I will split this according to law of indices. Okay, the school mathematics, law of indices. 2 raised to 32, I will write 2 raised to 30 into 2 raised to 2. Once again, law of indices. And I know 2 raised to 30 is 1 GB at the top. Observe it. Okay, I know 2 raised to 30 is 1 GB. So obviously, I will put that value. 2 raised to 30 is 1 GB and 2 raised to 2 is 4, which is a constant. So 4 multiplied by 1 GB is 4 GB. So the maximum memory supported by a processor of 32-bit address bus is 4 GB. Okay, that is the reason most of the modern laptops and computers, they support 4 GB because all our modern processors are 32-bit or they are 64-bit. Okay, and this is a homework for you. Complete this homework so that you will able to work on these simple problems. Okay, what is the maximum size of memory used with a processor with 16-bit address bus? Okay, that processor was 8085. So you can complete this as a small homework. Okay, I hope you must have noted, and I'm going back to our presentation and features. Okay. I already said that my processor is a hardware, and because it is a hardware, it is available as a 40-pin IC. Observe it. Okay, in fact, we have started with that. You can see. So this is my 8086 processor. Okay, and you can see there are 20 pins on one side and there are 20 pins on other side. Okay, and this particular symbol we use to count the pins. From this symbol, we go in anti-clockwise direction. So from this symbol, we go here in anti-clockwise direction. This is pin number 1. Okay, so this is pin 1, pin 2, pin number 3, and then it goes up to 40. Of course, we will be understanding those pins in, I think, third session. Okay, the hardware pins of 8086 as per lesson plan. Fine. Your 8086 processor works with 3 clock frequencies. You need to remember, one is 5 megahertz, second 8 megahertz, and 10 megahertz. Okay. It uses a technique called pipelined architecture. This question, I think I asked in the beginning, and we will be, of course, understanding. We are moving towards architecture. There are 2 important techniques used in 8086 for memory management. One is called memory segmentation, and second one is called memory banking. Okay, so if casually somebody asks how you manage memory in 8086, okay, then there are 2 techniques. One is memory segmentation, and second is memory banking. Okay, very significant for your examinations, and we'll be covering along with the architecture. Okay, finally, it's a hardware, so you have to program. So you can program using assembly language. Okay, you are aware, your C, Java, Python, these are all high level languages. But you can program your processor using low level language called assembly language or assembly language instructions. Okay, why, how, that all we will see in module 2. But these are 8 features of 8086 microprocessor. Little straightforward, you need to remember. Okay, some calculation part is there and some points you have to remember. Okay, anyway, now let's go on with architecture of 8086. But before that, let me take your questions. If you have any questions, my question is, any questions? Please check if you want me to repeat any point. Okay, IC stands for integrated circuit, and DIP is the layout of that IC. That means how pins are placed. Okay, it stands for dual inline package, DUALIN package, dual inline package. Okay, there is a question for 4th point. Okay, I will clear it. What is a clock frequency? Okay, this is expected. But anyway, this answer you will get in next 20 minutes. I'm going for architecture, and in that discussion, we will definitely bring significance of clock frequency. Okay, so wait for 20 minutes. You will get the answer. What is a clock frequency and why it is required? Okay. Anyway, but let me answer it referring to features. See, any microprocessor is a synchronous device. I think in COA, you have studied DL, that is digital logic. And you know, there are some circuits called sequential circuits, like flip-flop, and they work with clock. Okay, there is a timing. So in microprocessor, all timings you provide using a clock signal. Okay, how much time to read, how much time to write, those timings you get from clock frequency. Okay, more details coming. Anyway, now I can't see any other question. Fine. This package is called DIP. This is called DIP. Okay, 20 pins on one side and 20 pins on other side. This is called dual inline package. Okay. Type our magic words in chat box. Let me see all is well, because after a long time we are online. Okay, okay. Perfectly all right. All is good. Now let's start with architecture of 8086 microprocessor. Okay. You can see there is some familiar wordings on the title of my presentation, and that wordings are von Neumann model. Okay, you studied it in COA. I just want some words to get into architecture of 8086. I already said any program is always executed by a microprocessor, and any program which is under execution, you always store in memory called RAM, initial 1 hour. But I also said that memory can store, cannot execute and processor can execute, cannot store. So how this program will be executed? Because it's like missing link. Okay, somewhere there is a program and somewhere else it will run. For that, we use a model called von Neumann model. Okay, all computers today, they use this model. And why this model is required? Because this model works with three important concepts. One is a fetch, second one is a decode, and third is execute. I hope you will remember all those concepts. I just want as a reference. So if you want that your program should be executed and there is a gap, this is a gap, okay? You execute inside a CPU, you store inside a RAM. This gap, if you want to bridge, what you need are three important steps: the fetch, the decode, and execute. Okay. Can you tell me what is fetch, decode, and execute quickly in chat box? Short and sweet answer. What is fetch? What is decode? And what is execute? Let me see who gives the correct and the fast answer. What is fetch? What is decode? What is execute? Fetch means to collect the data. Okay. Correction is there. Input, process, output. No, there is a correction. Input, process, output is the functional blocks. Stages, no, again correction is possible. Fetching is bringing instruction from main memory to the CPU. That's a perfect answer. Very good. Instruction is fetch from main memory. Okay, that is a perfect answer. Very good. Fetch means to get data from the memory. That is partially correct. 10 seconds if anybody wants to add. Okay, exhausted. Anyway, great. But anyway, at least you can recollect and you attempt, okay? Because if you do, you will get. So if you attempt, probably it will be correct. Take instruction from RAM and perform execution. Yes, that is better. Decode means interpret. Yes, that's the perfect. Very good. Anyway, 10 seconds are complete. Let me continue. Fetch means processor will go to memory, listen my every word very carefully, because what I taught for 1 hour 15 minutes, it's a complete summary coming here. Fetch means your processor, let me take the help of the diagram, okay? I'm talking fetch, decode, execute, and I'm going back at 630. This is 630, okay? Here is my program. This is my processor. Processor will go to memory, identify where is a program through address bus, read instruction from that address via control bus, and bring that instruction into the processor via data bus. That operation is called fetch. Once your instruction is inside a processor, you interpret that instruction, you try to find meaning of the instruction, because what I fetch is I1. My program is I1, I2, I3, I4. Okay, some instructions. But what is I1? Is it add? Is it subtract? Is it compare? That is called interpretation. That interpretation is called decode. You find meaning of the instruction. And the moment your processor understands the meaning after decode, processor will actually perform the operation. If the instruction is add, perform addition. If the instruction is subtract, perform subtraction. If the instruction is compare, perform comparison. That is called execute. So if you apply little knowledge, you will agree that we start fetch, refer to memory, we go to decode, and then we go to execute. And we do it for each and every instruction. So my program is executed. Okay. Now the question is, we need to understand this in detail. Okay, because now this all details you have studied in COA. So background information, now we have to do and understand how actually it is done. Let's start with the architecture of 8086, and very first concept is a concept of pipelined architecture. I said in features 8086 is a pipelined architecture. Okay, let's start. Let us say this is my program. My program has 50 instructions. Okay, I1, I2, I3, like that. This is the time axis. One way my processor will execute the program is you fetch instruction 1, you decode and execute instruction 1, you fetch instruction 2, you decode and execute instruction 2, you fetch instruction 3, you decode and execute instruction 3, you fetch instruction 4, you decode and execute instruction 4, and complete all 50 instructions. Such approach is called non-pipelined architecture. So essentially, what your processor is doing, it is applying fetch, decode, execute sequentially, one after the other. And such architecture is called non-pipelined architecture. Your first commercial processor, 8085, whose age is 50 years, 50, was non-pipelined architecture by Intel. Okay, so basically the evolution of microprocessor started with non-pipelined architecture. Okay, but simple common sense will indicate that non-pipelined architecture is simple because it is sequential, but it will take more time to execute your program because you are doing one by one. Okay, you fetch, then you decode, then you execute, and then you do it for all instructions. So limitation of this non-pipelined architecture was time, performance, okay, is low. Time is more, performance is low. Intel designed second processor 8086, what now we are studying, using a pipelined architecture. Now let's understand what is pipelined architecture for 8086. Okay, let's say these are the timings for our reference. Okay, you can see that I will do fetch instruction 1 in T1. I will do decode and execution of instruction 1 in T2. Okay, I will fetch instruction 2 in T3. I will complete decode and execute of instruction 2 in T4, like that. Okay, so these are all the timings. What 8086 microprocessor does, it will fetch instruction 1. Okay, be very alert. It will fetch instruction 1, and when it is decoding and executing instruction 1, when it is decoding and executing instruction 1, simultaneously it will fetch instruction 2. Observe it. When it is decoding and executing instruction 2, it will fetch simultaneously instruction 3. When it is decoding and executing instruction 3, it will fetch instruction 4. I have taken 4 instructions for reference. Okay, these 4 instructions I have taken for reference, I1 to I4. Okay, and then I will generalize. And of course, it will decode and execute instruction 4. Now, if you compare this type of architecture, we call as a 2-stage pipelined architecture, with non-pipelined architecture. This processor is 8085 and this processor is 8086. There is a visible difference from this time diagram I call timeline. Visible difference is a non-pipelined architecture will take more time to execute, and pipelined architecture will take less time to execute, because instruction 4 is complete at T5 and same instruction was complete at T8. So obviously this will be faster. Okay, that is a very broad observation. Okay, these all minute details now we have to study. Okay, obviously all the processors after 8086 are based on pipelined architecture. Okay, there are hardly any processor which is non-pipelined. Most of the microprocessors now they are all pipelined architectures, but it starts with 2. Okay, now let's understand how these particular timings are significant. Okay, because somebody has asked one query, what is a clock frequency, or why we need clock frequency. Okay, I said you complete fetching of instruction 1 in T1. You complete decode and execute instruction 1 in T2. Question is that how these timings you will observe. Okay, because if you really want to do any task systematically, you have to manage in time. You have to make it synchronous. Okay, so how these timings you will observe, how you will say that fetch instruction 1 in time T1. For that, we use a clock frequency. Okay, what we have referred in features. Why? Reason is, it's a very simple relation. Maybe from school days, you are aware. Frequency and time, they are reciprocal. Okay, essentially what I'm talking is F equal to 1 upon T or T equal to 1 upon F. Okay, so what I'm talking here is a simple relation. I'm writing rough. T equal to, T means time. Okay, time is equal to reciprocal, that is 1 upon F. Okay, so time and frequency, they are reciprocal. So if I want to define this time, what I need is a frequency. And that is the reason every processor works with the frequency. Okay, let's take practical example for 8086. One frequency is 10 megahertz. Okay, 5 megahertz, 8 megahertz, and 10 megahertz. Okay, these three values we have referred. So if your processor is working with frequency of 10 megahertz, can you tell me in chat box what is the reciprocal of 10 megahertz? What is the time? Quick answers. If your frequency is 10 megahertz, then what is the time period? What is 1 upon 10? I'm interested in units, okay? And what I see is units are not correct. So if my frequency is 1 megahertz, sorry, 10 megahertz, then what is the time? Again, I'm waiting for few seconds. That is my question. It's a very simple fundamental question. Frequency is 10 megahertz. Yes. So finally, Harsh has answered the question. It is 0.1 microseconds. It's simple. 1 upon 10 into 10 raised to power 6. So 1 upon 10 into 10 raised to minus 6. 10 raised to minus 6 is micro. And 1 upon 10 is 0.1. So 0.1 microseconds. Okay. So this particular time is 0.1 microseconds. So your fetch will be complete in 0.1 microsecond. That is the reason your processors are fast. Sorry. But further, if you observe, if you decrease the clock frequency, that means if your clock frequency is 5 megahertz instead of 10 megahertz, then your time period will be 0.2 microseconds. That means this particular time will increase. That is the reason normally we say that higher the clock frequency of the processor, faster is the processor. That is the reason normally we say higher is the clock frequency of the processor, faster is the processor. Because if your clock frequency is high, this time will be less. Like I gave two examples. Okay. And that is how frequency is important, because that defines timings of all the operations. Okay. Check if you have any specific questions till this particular discussion. If you have any questions, then I will answer those questions before I go further. But anyway, today we are doing good because what we are planning, I think we will able to reach. We will enter the architecture of 8086. Okay. So any questions? Check it out. I'll take a summary of frequency. Yeah. Any other question? Are you there, or you are enjoying a nap? Okay. Okay. Let me answer that particular question. I can see only single question. What is the change in frequency? It means that there are three frequencies for 8086. Okay. If you take 10 megahertz, and if you apply this relation 1 upon 10 megahertz, what you get is 0.1 microseconds. Okay, so I can say that this T1 is 0.1 microseconds. But if your frequency is 5 megahertz, then 1 upon 5 megahertz is 0.2 microseconds. Okay, so this will be double. that is 0.1 and then double 0.2. That means time is more. So as the frequency of your processor will increase, your time to perform operation will decrease. It's because of reciprocal relation. That is the reason I said that we normally say higher the clock frequency of a processor, faster is the processor. It is not 100% correct, but yes, partially we can accept that a processor with high frequency clock will be faster in response. Okay, that is what I said using these examples, two different frequencies and how it affects the timing. Okay, there is one more question. Pipelined architecture does not require more buses. Okay, we don't require more buses for pipelined architecture, but we require some extra functional blocks to support that pipelined architecture that you will now see as we go into the architecture of 8086. So essentially buses will remain the same because buses are basically external. And this pipelined architecture is a part of designing of the processor. Okay, so you don't need any extra buses, but yes, some functionalities or blocks are required. That is the answer to your question. So your buses will be fundamentally three: address, data, and control, which is inside the processor. Okay, that is the answer to your question. I think I can move to the further discussion, that is architecture of 8086. Just type our magic word in chat box. Let me see how many of you are listening. Okay, many of you are listening. I'm happy to hear that. There is one more question which I should not miss. The two buses work at the same time. Yeah, that's a good question. Two buses doesn't work at the same time. Two buses works at the different times, but they do some task in parallel. The reason is that because it's a pipelined architecture, when you are fetching, okay, you are decoding and executing the previous instruction. So essentially you are working on address bus when you are fetching, and you are working inside a processor when you are decoding and executing. So that management part is required inside your microprocessor. Because two buses you cannot use simultaneously. So you need to manage it. Okay, that's the answer to your question. Anyway, now I'm moving to the last phase of our today's discussion because we are in last around 35 minutes. And of course, we will enter something called architecture of 8086 microprocessor. Now you can see a big diagram is visible on my presentation, and this diagram I have not drawn. This diagram belongs to Intel. Okay, there is a reference clearly visible at the end, and I have taken it from Intel manual. Okay, because these all diagrams are the ownership of Intel. I'm teaching what Intel has designed. Okay. Anyway, I said that your 8086 microprocessor is based on two-stage pipelined architecture. Let's start from here. Question is that how I'm going to do fetching of the instructions. See this. This is all fetch. Okay. And how I'm going to do decode and execution of my instruction. This is all decode and execute. Because you are doing two operations simultaneously. One is fetch, another one is decode execute. That's why it is called two-stage pipeline. because there are two important logical parts. In your 8086, there is a small functional block which is responsible to perform fetch. This is called BIU. Understand? This particular operation is done by BIU. It stands for Bus Interface Unit. Okay, BIU stands for Bus Interface Unit. So essentially, this particular function is done by BIU. Okay, and all decode and execute this particular operation. All decode and execute is performed using second part, which is called EU. EU stands for execution unit. So because your architecture is two-stage, there are two logical partitions inside your microprocessor. One is called BIU and second one is called EU. Okay, you can clearly see in the architecture diagram. Observe it. You can see this is called BIU, Bus Interface Unit, and this is called EU, that is called execution unit, and you can see this is logically divided. Okay, so your 8086 processor has two logical parts. Bus Interface Unit responsible for fetch, and execution unit responsible for decode and execute. Okay. Today we are going to start with BIU and progressively we will go to EU. Let's start with BIU. Let us assume that this is my 8086 microprocessor. Okay, you can see the outline. Okay, this is a dotted line, which is an outline. So this is my 8086 microprocessor with two logical parts, the BIU and EU. Okay, and let us assume that this is my memory, okay, called RAM. Memory interface means memory connection. Interface means connection. Okay, we will study this interface in module 3. So interface meaning connection of memory, okay, with processor. I'm sorry. And let us say that this memory is RAM, where there is some program stored, I1, I2, and so on. Okay. Again, the same thought. My processor will execute the program and my memory stores the program. Okay. So what my BIU will do, okay, BIU of 8086 processor, my BIU will refer to the memory. Observe it. Okay, my BIU will refer to memory via system bus. So this bus is a system bus. And I hope you will agree. System bus means address bus, data bus, and control bus. Okay, they are all together. They are used in particular sequence, which you already know. My BIU will refer to memory using system bus. Address bus tells what is the location my program starts or instruction I1 is stored, and this instruction I1 is read through control bus, and this instruction I1 is brought into BIU using a facility called queue. Observe it. Don't worry, I will repeat. Okay, now there are some references which are visible. What you see on one side is a pipelined architecture. Okay, And currently we are talking about fetch. Okay, this particular operation currently we are talking, and this fetch, okay, is done using BIU. So basically bus interface unit is responsible to handle all fetch. Okay, go to memory and get the instruction. Let me again repeat. BIU of 8086 will use a system bus to refer memory where program is stored. Address bus will tell what is the location program starts. So through address bus, processor will identify start of the program or instruction I1. Through control bus, processor will read this instruction I1 from the memory, put it on data bus, and through data bus, my processor will bring this instruction I1 into one facility. You can see this block called instruction queue. Observe this, instruction queue. Okay, there are some numbers if you observe 1, 2, 3, 4, 5, 6. This particular block is called instruction queue. Technically, it is called instruction stream byte queue, but let's call instruction queue for simplicity. Okay. Now, what is instruction queue? Let's understand. And that's the main objective for the day. Instruction queue is a small memory. It's a small storage which stores the instruction temporarily. Okay. So what BIU will do, BIU will read instruction 1, instruction 2, instruction 3, instruction 4, instruction 5, instruction 6, and it will put it in this particular queue. It's like a buffer. BUFFER. Okay, now the question is why this buffer is provided. What is the significance of this particular buffer? This buffer, this storage is provided because there is a speed difference between BIU and EU. Understand? Because who fetch the instruction? BIU. Who decode and execute the instruction? EU. But they work at different speed. Okay, BIU works little fast. EU works little slow. It's like 5 fingers which are not equal. Okay, so BIU does only fetch. So it is comparatively faster. EU does decode and execute. So comparatively it is slower. And you need to bridge this particular difference. Okay, it should not happen that BIU is going ahead and EU is behind long back. Okay, we need to sync it. We need to synchronize it. For that, we need this facility called instruction queue. Okay, let's understand how it works. What EU will do, of course, EU I'll be discussing in next session. I'm only taking reference. EU will take instruction from this queue. Observe this carefully. Okay, this is a part called EU. So EU will take instruction 1 from this particular queue so that instruction 2 will come to the position of instruction 1. So this is a moving queue. Okay, it is not a fixed queue. This queue can move. Okay, instructions can roll. instructions can pass from one point to second point. Okay, let me make it little clear through a small diagram here. See, this is my queue. Okay, little rough diagram for clarity, only I'm drawing a diagram. Let us say that this particular instruction is instruction 1, and let us say that this particular instruction is instruction 2. Okay, and who brings instruction in queue? DIU from RAM. Now the moment this instruction 1, you take it inside the EU for decode and execute, this instruction 1 will be replaced by instruction 2. So instruction 2 will come to the position of instruction 1. And if this is instruction 3, then instruction 3 will come to the position of instruction 2. So here you get instruction 3. Okay, so that some space will be created at the top. See this. This is where your space will be created, because if you take instruction 1, then 2 will come here, 3 will come here, 4 will come here, 5 will come here, and 6 will come here, so that some space will be created here where next instruction can be brought by the BIU. So in very simple words, what I'm talking for last 7 to 8 minutes, in very simple words, why this queue is important? Because this particular queue, let me draw it, this particular queue, on one side, your BIU will fill the queue, FILL, and from other side, your EU will drain the queue. Okay, so from one side, BIU will put the instructions 1, 2, 3, 4, and from other side, EU will take the instruction. 1 is taken, okay, 2 will move. 2 is taken, 3 will move. 3 is taken, 4 will move. 4 is taken, 5 will move. Okay, so at the top, space will be created, and BIU will go on adding further instruction. Such queue is called FIFO queue. This is a word, FIFO. FIFO का मतलब है first in, first out. Okay, FIFO. You are studying data structures, so you are aware about these particular words. Okay, you are aware there is something called queue, there is something called stack, there is something called linked list, there is something called tree, there is something called graph. Okay, you might have started or you have studied data structures probably in previous semester. But this queue is basically a FIFO queue. The queue such that the instruction which comes first is the instruction, okay, which goes out first. It's a sequential FIFO queue. On one side, your BIU will fill the queue, and from other side, your EU will empty or drain the queue, and continuously you will find there is a flow of instructions in this particular queue. Okay, I1, I2, I3, I4, I5, I1 taken, I2, I2 taken, I3. That way, there will be a continuous movement of instruction. That's why it is called instruction stream. Observe it. Stream का मतलब है flow. There is a flow of instruction in that queue. Okay, and why we do it? I think already I said this queue is required so that even if EU takes some time to decode and execute, BIU will be busy. And by the time your EU takes instruction 1, decodes instruction 1, execute instruction 1, BIU will go and bring instructions 3, 4. Okay, so that resource utilization will be better. Otherwise, the problem is that if there is no queue, then BIU has to wait till instruction I1 is complete. And then instruction 2 will be taken up. Then BIU has to wait till instruction I2 is complete. then instruction I3 will be taken. Okay. So very significant part of BIU, that is called instruction byte queue. Okay. Check if you have any further questions. Otherwise, I will go ahead with remaining part of BIU, which will definitely roll on because there is something new called memory segmentation, which we are going to talk. But anyway, before I talk anything further, let me take your questions. So my question is, any questions? Please check it out. Any specific point or any questions? If you want to ask, you can ask. Okay, at least I can see one response, second response. Okay. Okay. I will talk about mapping to examination. Okay. Yeah, I understood. Mapping to examination in college or maybe university. I understand, Sanjana. I will talk about it. I'm just waiting if any other questions are coming. Okay. Let's now try to. Okay, Vivas also. Okay. Let's now try to map with examination, which is significant for you because digits are important. My observation is that, yeah, that also I will communicate. Do we have to remember this diagram? Yes. See, in 2-3 years ago, what trend I'm observing is that there was a full-fledged 10 marks of questions that was asked, explain architecture of 8086 microprocessor. Okay, so you should be prepared for it because engineering means everything is unpredictable when it comes to examination. So any question can be asked. So you might get one question, explain architecture of 8086 carrying 10 marks, where this diagram you need to practice and you need to remember. Okay. But recent trend is that they are asking small questions based on the architecture, like what is the use of instruction queue in 8086, 5 marks. Okay, so whatever we discussed, that you have to write that it is a FIFO queue. BIU will refer to memory using system bus. It will bring instruction in a queue. On the other end, you will read instructions. It will empty the queue. Okay, and this we used to manage speed difference between BIU and EU. Such questions are normally asked in recent exam. They asked the small functional blocks of your architecture. This is one more possibility. And of course, in your Viva oral examinations, you get very general questions. Why you need a queue? What is the size of the queue? Okay, those digits, what you see is basically size of the queue. It's 6 byte. Okay, so you can store 6 byte into those particular queue. So you cannot bring entire program. You can only bring instructions up to 6 bytes into the queue. So 6 byte queue. So what is the size? 6 byte. What is the nature of the queue? FIFO. Why you say queue is FIFO? Okay, such questions are normally asked. Yes, it is called as 6 byte prefetch queue. Prefetch may not be the correct word in 8086 because that word is used for high-end microprocessors. But loosely, you may say that it is a prefetch queue. Perfectly okay. Okay, I think I have answered those questions. Okay. Anyway, that is also very good practice. If you can write all possible questions at the end of the notebook, you will have a good collection of question bank at the end. Okay, because I think in between I always map with examination. Okay, now let's go for last 10 minutes of today's session and make a base for session 2. Okay, the big session for memory segmentation. A quick summary, and then we will introduce memory segmentation. I said BIU will fetch the instruction, EU will decode and execute the instruction. BIU will refer main memory, RAM, using system bus. Through address bus, it will find where is the instruction or a program. Through control bus, it will read the instruction. Through data bus, it will transfer the instruction from memory into a facility called instruction queue. The moment your instruction is in instruction queue, operation called fetch is complete. So this instruction queue is used to support operation called fetch. मेमोरी से रीड किया और इंस्ट्रक्शन क्यू में स्टोर किया, that is what is a fetch. Okay, it is a 6-byte queue, it is a FIFO queue. From other side, your instruction will be taken by EU for decode and execute, so that when you take instruction 1 for decode and execute, automatically instruction 2 will come to position of instruction 1. This is what I said. So it is a moving queue. Okay, just like our day-to-day example, ki 10 people are standing in a queue for BEST. Okay, BEST comes. First person goes inside the bus. Obviously, second person will come to the position of first person. Then second person goes inside the bus. Third person will come to the position of first person. 3, 2, 1. Okay, that way it is a moving queue. So those person is like an instruction. Okay, that queue is like your instruction queue, and that bus is like a EU. Okay, that is the simple analogy. So it's basically a moving queue, and this queue is required to bridge gap speed difference between EU and BIU. So by the time EU takes instruction 1, decode, execute, during that time your EU will bring instruction 2, instruction 3, and it will keep it handy. Okay, now let's move with this quick summary. I hope this is very clear. Now the question is how my BIU will work and find what is the location instruction is available, because that is where story starts. Okay, fetch starts, where to go via address bus. For that, in 8086 we use one memory management technique, and that memory management technique, it's called segmentation. Okay, it is called memory segmentation. Okay, let me introduce memory segmentation. Okay, we are in memory segmentation. See, memory segmentation and architecture goes hands in hand. So both these concepts we are going to complete together, memory segmentation along with architecture. Okay, now let's discuss something simple for the day. Now, what is memory segmentation? You are aware that maximum memory RAM supported by 8086 is 1 MB. Okay, all reasons, justifications we have discussed. This 1 MB memory is divided into a logical partitions. So it is not continuous. Okay, but there are some logical partitions. And those partitions are called segments. We will understand why, how, all that. Every segment is of size 64 KB. Okay, this you need to remember. So what is the size of segment in 8086 processor? 64 KB. So essentially, what is done in 8086 processor? 8086 processor looks at the memory not as one unit, but it looks at the memory, which is 1 MB, in terms of small logical partitions, and every partition is called segment. Okay, and size is 64 KB. There are 4 types of segments in 8086 memory. This also you need to remember. So what I'm bringing is a very fundamental for the day. One is called code segment. Second one is called data segment. Third is called extra segment. And fourth is called stack segment. Okay, तो कितने segments होते हैं memory में? 4 for 8086. Code segment, data segment, extra segment, stack segment. All segments size is fixed, 64 KB. Okay. How it looks? Of course, I will talk about fourth point. But how it looks? Let's see the diagram. Suppose this is my memory called RAM. And this is the reference of our architecture. Okay, what you see on other side. So this is the architecture we are currently talking, BIU. And this is a memory, okay, which I'm exploring. This memory I'm exploring. Then you can see this particular memory, which is 1 MB, I'm dividing in small red colored partitions. You can see. Okay, this is one partition. This partition is called code segment. This is another partition. Okay, this particular partition is called data segment. This is called extra segment, and this is called stack segment. Okay, so 4 different types of segments are possible: code, data, extra, and stack. All are 64 KB. You can see. Okay. Now let me tell you why this is done. Okay. उसके बाद हम लोग रुकेंगे क्योंकि यहां से हम लोग आगे कंटिन्यू करेंगे नेक्स्ट थर्सडे. ठीक है, क्योंकि ये मुझे नेक्स्ट थर्सडे को यहां से चालू करना है. ओके, why it is done? Because this is a very logical answer. Let's start with code segment. Code segment is always used to store program. Okay, if you want to store any program in your memory, you will always store in code segment. Okay, that means if my BIU wants to refer memory to fetch the instruction, what we discussed, if my BIU wants to refer memory to fetch the instruction, my BIU will not refer 1 MB memory, but it will refer small part called code segment, which is 64 KB. Because what BIU is fetching? Instruction. What is the instruction? It's a part of a program. And where you store the program? In code segment. Because just now I said code segment is used to store all programs. That means if you do partitioning, then you don't have to look anywhere else. You don't have to look entire 1 MB, but you have to look a small part of 1 MB, which is 64 KB. So you are more focused. That is the reason this management technique is used, because your searching becomes less and time to locate the instruction will be faster, क्योंकि आप 1 MB की में नहीं देख रहे हो, आप 64 KB में देख रहे हो. And just for your kind reference, 64 KB multiplied by 16 is 1 MB. तो 1 MB में 64 KB के 16 सेगमेंट्स हो सकते हैं, 16. Okay, so you are reducing your entire focus to 64 KB. That's why this technique is very, very significant. Anyway, now time to conclude today's session. Just last couple of minutes. Yeah, that now I will answer in coming session why there are remaining segments. Okay, because I just talked about code segment. But now for that, we need to have a complete discussion of memory segmentation. So of course that we will continue in the next session. Okay. Anyway, but before we end up, if you want to ask any questions about anything, you can raise your questions. Yeah, I will show the slide of memory segmentation. I'm going back. This is where I started memory segmentation in 8086. Don't worry, these slides also I will be sharing in a form of PDF. Okay, I will share with the office, and through that it will go to the app. So this all will be available to you maybe in next 1 or 2 days. I think I have said in the beginning that we have an app called StudEase app, STUDEASE, and on that app, okay, no problem. On that particular app, all the notes will be shared. All module notes are ready. Okay, and they are all my notes only. So basically, what I'm teaching almost in the same lines you will find. And additionally, I said that these PPTs I'll be sharing as PDF, क्योंकि वो भी notes जैसे ही है, उसपे सब points, definitions, diagrams वगैरह सब कुछ है, which is additional reference. That's the answer for the query. Okay, I think, yeah, most welcome. You don't start revising microprocessor, because microprocessor we have started today only. So I will suggest that in week 1, you try to read some concepts of COA, the fundamental concept like memory organization, processor organization. Okay, what is fetch, von Neumann model, and whatever discussion we did for microprocessor today, that part you study, like what is a bus, types of buses, significance of buses, features of 8086, then pipelined architecture, and of course BIU. Okay, we have started with instruction queue, so that way you can start studying microprocessor. Okay, anyway, I think I have answered all questions. Anyway, so that's a great start for the day and for the microprocessor. So let's continue for next coming almost 13 weeks. Okay, and next session we will focus on memory segmentation, and we will try to complete BIU, and we will enter EU. Okay, where we will have some registers and try to complete architecture of 8086. Okay, thanks a lot. Have a nice weekend, and let's continue next week, Thursday, 6:30. Thank you, and have a great time. Thank you. Office, you can end the sessions. Thank you. Thank you. Most welcome. I'm honored that you are getting benefited. We can end the session if somebody is hearing me.
Okay, sir. Thank you.
Okay, thank you, and good night.
Good night, sir.